Good morning. Thanks for coming this morning. I'm going to be speaking about enabling greater sustainability in vehicle fleet sales through customer-oriented analytics. This is joint work with my colleagues at Ford Research, Sandy Winkler and Erica Clamfel, who's here in the room with us today, and another one of our colleagues who's in North America, Fleet Lease and Remarketing Operations Division of Ford, Natalie Olson. So quick intro to the system. It's called the Ford Fleet Purchase Planner. It's an analytical system that we developed to help large organizations plan new vehicle purchases. So if you think about a large organization, it's very different than the individual buyer. They're going in to purchase 1,000 or several hundred vehicles at a shot. And what we've done is we've transformed this one-size-fits-all approach that they've traditionally took. And the reason they took that approach was it's simpler to think about all of your drivers that have a similar job responsibility and get them all of the same vehicle model. And what we've done is we've introduced an industry-first mathematical approach. We've made a web application to make it really flexible, easy to use. And this is helping our customers find opportunities where they can increase their sustainability in a really cost-effective way and do it very conveniently using optimization. And the key to that optimization is having driver-level precision. And I'm going to be talking a lot about the driver throughout the talk. So analytical systems, one of the challenges you run into is you do all this complicated math and analytics, and then you want to try to message that out pretty simply. So what you're looking at on screen is something that our marketing group put together to break down our system into 6 steps that we can really message well to our customers. The first is thinking about purchasing a new set of vehicles for your fleet. And then thinking about what you've currently got, the old vehicles that you're going to be removing, and trying to better understand what those vehicles have done for you in terms of sustainability and costs. After that, you'd start thinking about replacements. So you'd get into thinking about all the different vehicles that Ford's selling and how those might fit into the fleet. And step 4 is where the data analytics starts, narrowing down that field of choices to really hone in on the right one for each driver. Putting finishing touches on, thinking about different cost considerations that you have, financial goals, environmental goals, and then step 6 is coming out with that really great sustainable purchase that's also going to be very cost effective for your organization. So this is a quick overview. Now for a customer who we went through this process with, Kone Elevators and Escalators. So if any of you look down at your feet when you're going down the escalator, you may have noticed Kone's logo at the bottom. They're one of the biggest. And they were planning their purchase for their vehicle fleet, which goes around, does a lot of servicing and other tasks as well. And they had some ideas of what they were going to purchase. And we went in and we did a driver-level analysis with them and optimization, and came out with a recommendation that saved them 850 metric tons of CO2, and it saved them money as well. So making that reduction a little bit more tangible for you, this would be like taking a square mile of mature trees in a US forest, waiting a year while those trees are absorbing CO2, and we got the same successful savings just through a smart purchase decision. If you thought about planting new trees now, you'd have to plant 20,000 seedlings, wait 10 years. To get the equivalent CO2 reduction that we got through this purchase. So this is one company, one purchase, a really massive environmental improvement through it, just by smart analytics. Fleet customers like Kone are a huge part of Ford's business. They're about 30% of our overall sales as a company. And again, they're purchasing hundreds, thousands of vehicles at a shot, which is what gives them this potential for doing these really great achievements in the sustainability. They're very attentive to cost, to fuel costs and other costs, and increasingly each year more and more of these companies have actual sustainability targets that their management or that for government agencies that the public wants them to achieve. So other examples of companies here, McDonald's, Travelers Insurance, Hertz Rent-A-Car, the list goes on and on. Ford's strategy towards sustainability is a little bit different than you'll find at other automakers. So one of the things that makes us unique, and we refer to this as the power of choice, is the variety that we offer within an individual vehicle. Who here is an owner of a Ford? Don't be shy. OK, any Ford Fusion owners? Great, a couple. So for those of you who aren't familiar with the Ford Fusion, this is our mid-size vehicle. It's comparable to a Honda Accord or a Toyota Camry or a Chevy Malibu. But what's unique about the Fusion is you could get this Fusion with a 2.5-liter conventional engine, traditional engine like you've normally probably had in vehicles in the past. Then you could get it with an EcoBoost engine, which is direct injected and turbocharged. It's a smaller engine, but it gives more power, so you get this fuel savings. If you want to move greener from there, the Fusion's offered as a hybrid vehicle. Hybrids are pretty mainstream, so you may be familiar with them. They have a small battery. While you're driving, they're collecting energy through things like braking, where the electricity is recaptured and then used to improve the efficiency of your drive cycle, achieving more mileage per gallon overall. And from there, you can even go a step further into a plug-in hybrid vehicle, where it has a larger battery than the hybrid. You can plug it directly into an outlet in the wall. And if you're doing short distance driving, you could pretty much exclusively drive the vehicle off of electricity using almost no gasoline at all, except for longer distance trips. So that's one vehicle in the lineup, and you can see the spectrum of offerings that we have for sustainability. And we apply that strategy to all of our vehicles, where we have multiple different green technologies available. But those technologies pay off for certain drivers, depending on how you drive. For other drivers, they're not as cost effective. And that's where this driver level precision of our system really comes into play. So the Ford Fleet Purchase Planner is really geared towards helping better understand how to buy these technologies for your drivers to maximize their effectiveness, satisfying corporate environmental goals in the most cost-effective way, analyzing this relationship between cost and sustainability, which up until now has been pretty difficult to understand, and doing this again at the driver level detail for your specific fleet so that it's all customized. And that's where the power comes into the system. So stepping back to the backbone, a couple years back, the fleet organization came to us when we were first introducing some of these new green technologies. Customers weren't really familiar with them yet. And they said, can you develop some sort of tool for us to show customers what these will achieve in terms of sustainability, to help think about this in a more quantitative way? And we put together this calculator. And now you can go online. You can find similar calculators at the EPA website. At the time, this was really a first-of-its-kind technology. Basically, you pick two vehicles. They could be two Fords, like a Fusion 2.5-liter conventional engine versus a hybrid. Or it could be a Ford versus a Honda or a GM. And you'd put in how many miles the driver goes each year, how many years they intend to keep the vehicle, what they expect to pay at the pump, or if they're looking at an electrical vehicle, what they're going to pay electricity rates. And when you put that info in at the bottom of the screen, and I know the details aren't so clear, you'll get basically a full report on sustainability and operating fuel costs. And so this was a game changer in terms of how Ford's salespeople and how our customers both thought about sustainability. It went from sustainability is really great and we want it to here are the numbers on sustainability, and here's how you can measure what's worthwhile for you and your company. And so we thought the idea on this had a lot of power that we wanted to really extend towards influencing on a much larger scale, not just a one-to-one comparison, but taking a look at 1,000 vehicles and thinking about planning a new purchase for those vehicles. And that's where we got into a more advanced analytical system. So you're seeing here a screenshot of a web application that we developed where you upload a file of customer data. And so when you upload that file, it pops up in the application. And one of the key pieces of information here are VIN numbers. And this is to make sure the system is easy to use. So I'm going to talk a little bit about how this works. Who here has heard of a VIN number? OK. So what you may know about a VIN number, what I knew before I worked on this project, is that the DMV in Michigan, where I live, has my VIN number in their records. And if they look that up, they can see Daniel Reich owns a Ford Fusion. It's 2012. And and they could get other information as well. What I didn't know is that VIN number is something that you can actually decode in a way that gives you a lot of information. And so if we think about a real obstacle to influencing purchase decisions through optimization, that's data. If we have to ask customers to clean up their data into a certain format that we want it in, and they've got 3,000 vehicles, this is an enormous task. It's going to be a huge burden, and it's going to be an obstacle to using a system like this. So if you think about allowing customers to send us whatever data they have, and we wanted to use the data in whatever format they have it, if we go to things like the name for vehicles, one company might call a Ford vehicle Ford Motor Vehicle. Another might call it a Ford MC. A third might call it FOMOCO in their records. And so we'd have to systematically be able to parse all of this information and make sense out of it, which is extremely difficult given that the records are kept even with different pieces of information, aside from the fact that those pieces of information themselves are written differently. So we needed to avoid this, and we did it with the VIN. You can break apart the 17-character VIN, and the first 3 characters will give you the manufacturer, which in this case is a Ford. The next 5 will tell you about the vehicle itself, which is a Focus Electric. The 11th character tells you the model year. There's a lot of information you can pull off the VIN, and in fact, in our web application, we pull the year, the make, model, the engine displacement, which is how many liters it is, how many cylinders it has, what type of drive it has, front wheel, all-wheel, rear-wheel drive, the body style, and we don't have to worry about how the customers maintain their data. Everybody has a list of data on their vehicles that includes VIN numbers. That's one aspect of the dirty data we had to deal with for the problem. The next is external data that we need to pull in more information about these vehicles. So now we know what vehicle it is because we've decoded the VIN, but we don't know things like what's its mileage per gallon, what segment is it, which I'm going to talk about more later. So if we think about mileage per gallon, the Environmental Protection Agency in the US, or the EPA, maintains those records. And they have a database that you can access. Any of you can go and download it. And what you'll find when you download it is a formatted database. So they'll label a vehicle, maybe Ford Motor Co. They'll call Focus BEV for battery electric vehicle. Since it's a BEV, it doesn't have an engine, so they label that as a 0.0 liter engine, front wheel drive 2014. These are all pieces of data that we have aspects of coming out of the VIN decoder. So we can match up some of these exactly, like model year, no problem, 100% precision, easy. Things like the 0.0 liter engine or the size of an engine, we can match that up easy. Again, we have to deal with different naming conventions and some of this data which is fuzzy and doesn't match up as nicely. And we've developed different techniques for doing that in a very highly precise way. And so the data is really the key to our descriptive analytics and to getting us in a position where we're going to be able to optimize. And so what we've done is we've transformed that initial calculator that I showed you, that's a one-to-one comparison, into a calculator that can upload thousands of vehicles in a few seconds' time, give you a full report vehicle by vehicle, and an overall assessment of the fleet as a whole, both in terms of its fuel costs and in terms of its emissions levels. So now we're ready for the fun part, which is planning the purchase. Show of hands. If there's a driver who drives a truck, an F-150, who thinks our smallest sedan, the Fiesta, is a good replacement for the truck? Show of no hands. Great. That's right. So logically, that's easy for us to think about, right? If they have a truck, they probably need the truck to do certain things. You know, they're not taking a tiny car, except maybe in rare circumstances. But systematically, if we think about this, how do we process all this? So this is another place where we pull in external data, and it's called segmentation data. Who here has gone and rented a car? OK, a lot more hands there. Great. If you've gone and rented a car, you know they ask you, do you want a compact, mid-size, full-size, SUV? These are called segments. So what we do is we look at each driver in the fleet. So we see this F-150. We go to an external data source. We find out, oh, that's a segment of truck. And then we look at everything we're selling within that segment of truck. And we find all these different F-150s that we're selling with different levels of sustainability. And so these, by default, are pulled into the system as candidates for replacing this old F-150. But we need this, again, we need this system to be extremely flexible for our customers. Like I mentioned, there may be instances when you want to make these changes and you want to go from an F-150 to an Explorer or to some other vehicle that will be a good adjustment for the job responsibilities you have. And so we needed, in addition to doing this under the hood, a flexible interface where you could customize. So what you're seeing on screen here is an old Honda Accord from 2008 that they have in their fleet. And what we've done by default is matched it up with the 7 different Fusions that we are currently selling. If the customer wanted, they could move these Fusions out of this candidate replacement set and drag in some new other vehicles that we're selling, such as an Escape, for this specific vehicle. So to give you an idea, probably at least like 95% of the replacements in a fleet, the defaults we set are the right ones, but there are these instances when you want to have the flexibility to customize as well. And so now we're ready for the optimization part, the prescriptive analytics. And what we're doing is we're selecting for this 2008 Accord which one of those 7 Fusions is the best one for the driver who drives this vehicle. Again, that driver level precision. And so how we do that, we have decision variables that are binary. They're created for each of these candidate replacements that we identify. So for example, with the Honda Accord with the average mileage of 15,771 miles a year, we create a decision variable that lets that Accord be replaced by a Fusion 2.5-liter engine. Another decision variable that lets it be replaced by an EcoBoost, one for a hybrid, one for a plug-in hybrid. These are all yes, no, are you going to buy this as your replacement? There are actually 7 decision variables, but 4 was enough for the screen. Flow balance constraint makes sure that you purchase one of them. The emissions constraint is at the heart of the system. It's ensuring that the company can get the sustainability achievement that they want. So again, going back to our descriptive analytics, the batch mode calculator that assessed the full fleet tells us this is how much emissions they have now. If the company wants a 5% CO2 reduction from there, the right-hand side of this constraint is what lets us ensure that we can give them a recommendation with that. Integrality constraint, of course, we're purchasing full vehicles. And the objective is a cost objective, but it's a customer cost objective. It's making sure for the level of sustainability that the customer wants, this is the most cost-effective way to get it. And so here's an example of a customer we worked with that had 747 mid-size vehicles they were looking to replace. And they came to us and said, you know, we're thinking about getting all EcoBoost engines, which is one of our green technologies. And what we did was we ran the optimization model we just went through, and we showed them that you can actually achieve the same thing by getting 67 EcoBoosts. 611 of your drivers, you can go to a less expensive technology option, our base 2.5-liter engine model, and get 69 drivers hybrids for those drivers that can really make the most effective use of the hybrids. And the reason this is optimized for you is you'll save $250,000 doing it, because you've invested in those technologies where you can get the most bang for your buck. If you think about customer financial factors, there's varying cost metrics for that. So in the example I just gave, you're thinking about purchase price, price plus fuel, price plus fuel plus maintenance is another level you can go to. You can add in things like insurance rates, or even get to the level where you're analyzing resale value when you're going to be selling this vehicle later on. And that most detailed level is known in the business as total cost of ownership. And so I wanted to give an example of why different companies would be interested in different metrics. So if you think about Hertz Rent-A-Car, you go into rent a car, you pay for the fuel, you fill it back up, right? It's not a cost that Hertz really has to consider for these vehicles in their cost structure. But resale value is a huge one for them. If you go to rent a car, they're new cars. 9 months later, 12 months later, they resell that vehicle. That's a major cost component. If you think about a construction company, They may buy a truck. They may run this truck 250,000 miles till the truck is pretty much done with its lifetime. Resale value is not a major factor for them, but they're paying for all that fuel, so fuel cost is. So again, to develop the system in a way that it was really most useful for a wide range of all of our customers, we need the flexibility to use different cost metrics in the objective function of our optimization. There's also uncertainty in these costs. So if you think about something like fuel and a company that's going to be keeping the vehicle for multiple years, the price of gasoline may be $3, $4, $5 a gallon. Who knows? Similarly, the resale value for Hertz, where they're going to sell it 9 months, 12 months later, that's probably something you can estimate with pretty good accuracy. If you're thinking about selling a vehicle 7 years later, who knows what the supply and demand of used cars is going to be at the time, or what the overall economic situation in our country is going to be. If we're in a period of growth, what the interest rates are. So you have all these uncertainty factors. Customers provide us their costs when we do these optimizations, and that's necessary. Even something that doesn't have any uncertainty, which is the purchase price, that's actually known, we don't know it. There are laws that prohibit automakers from selling directly to customers. That's for individuals. It's also true for fleets. So these fleet customers have to buy through dealerships. The dealers interface with Ford. And so if we want this system to be accurate and be able to give customers unbiased information that's directly applicable for their fleet, the cost information has to come from them, and it does. And so again, we have that cost optimization model that we went through. We have a second optimization model that's very similar that focuses on the objective of minimizing emissions, and the cost becomes a constraint. And we use these two models interactively. And so the idea here is to not just give the customer a single recommendation for one level of sustainability. It's to give them a spectrum of recommendations showing different levels of sustainability they can achieve and the costs associated. So we optimize for costs with a loose emissions constraint, and then we keep tightening and tightening and tightening. And what we come out with is a Pareto frontier on cost versus sustainability. So if you look at the bottom left corner here, for about $370,000, and this is a toy example, it's not real customer data, this customer can get a 23.4% reduction from their current state of emissions. If they spend $100,000 more, their maximum sustainability level that they could achieve based on the technology we have to sell today is a 42% reduction, just about. So this is a high-level view that really shows financial versus sustainability. Then we get into a high-level view that shows what the vehicles look like for each of those points. So it's color-coded. This purple section up here, this represents Fusion 2.5-liter vehicles. You move to more sustainable, you start buying EcoBoost, which is this yellowish, greenish color. You then get some hybrids, this blue. And as you move across, you get more and more blue till you're fully hybrid. And it goes vehicle type by vehicle type. We have all that information in a chart, of course, as well. And so with these three outputs, the customer is in a position to decide, where do we see ourselves strategy-wise? What level of sustainability do we want to achieve? And then we can give an extremely detailed report that says, vehicle by vehicle in your fleet, what do you have now? What are we recommending you purchase? And how do those compare in terms of their emissions and fuel costs? And there's one last step, which is a sensitivity analysis around the uncertainty. So how robust is this purchase if you make it? If fuel costs jump $1 or they decrease $1, how is that going to affect you financially? So why this is an innovative analytical application? The descriptive analytics here are, again, something that did not exist before we developed the system. There was no way to analyze a large fleet of vehicles efficiently and to make that really easy for the customer and to enable them to utilize this system that we've developed. We introduced those VIN decoding techniques so that we could just take their data as is, and these fuzzy matching algorithms to be able to match up their vehicles with the external data sources like the EPA that we need. And that put us in a position to do the prescriptive analytics that we wanted to do, which was optimization. And optimization for the customer to achieve sustainability reductions, sustainability increases, emissions reductions for them in the most cost-effective way possible. And we showed with the one example from Kone up front what a major impact that this can have just for a single customer. And we have, again, 30% of Ford sales are these large fleet customers. So the value that it's bringing is analytics are now for the first time at the forefront of vehicle purchasing, which traditionally has been more of a face-to-face kind of deal. Again, helping customers increase their sustainability and an industry-first technology here in doing it. So here's a short video clip that highlights some of the things that we show to our customers regularly at events throughout the year.
With all these different alternative fuel technologies and advanced engine technologies, a lot of questions probably still remain. And to answer those questions, we have a dealer network called our Business Preferred Network.
What are your best options for your drivers and their behaviors? Maybe some of your drivers would fit well into a hybrid, maybe others would be a great candidate for an EcoBoost. Since we have all these different technologies at Ford, there's no one answer for any given customer.
The biggest challenge is, will an alternative fuel provide the performance that I'm used to with gasoline or that I'm used to with diesel? And I can tell you, without a doubt, all of these alternative fuels provide the type of performance that will get the job done for you. The question is, will it get the job done efficiently and economically for you? And that's where the challenge comes in for people to choose among the myriad choices.
So the Fleet Purchase Planner is a project we started about a year ago, and we wanted to do something to help our fleet customers in particular understand their different product and technology options.
The customer will tell us, here's our mileage and here's how we drive it, and then we'll put that information into the calculator and it'll provide a picture on the fuel costs, it'll provide a picture on the emissions. Okay, so last slide here, I just wanted to highlight some things about the project. We've published 2 papers in the technical community, one at SAE, which is a major automotive conference each year, and one at last year's International Conference on Operations Research and Enterprise System, and that actually received the Best Paper Award at the conference. We've had a lot of press, so you can see this section on press. This is fleet press. This is from the fleet world, showing how novel this approach has really been to the industry. The video clip that you saw, and sorry about the sound there, they're on YouTube, longer versions of those videos that are shown to customers and that are out on Ford's Facebook page. We're grateful to have been selected as a finalist for this award. We're also currently being considered for an internal award at Ford called the Ford Technical Achievement Award. That's going to be decided next month. We filed a patent, and the system's been trademarked. So thank you again for coming today and for listening to the talk. I hope it was interesting, and happy to take any questions.